Hey guys, it's Mr. Moog. I'm going to take you through some of the problems on this test review today. I'm not going to do every problem, and I have linked in the description of this video the different problems that I've done. So if you want to just skip ahead to the different problems, feel free to click those. I'm going to do A, D, E, and G from number 1, part of number 2, all of number 3 and 5, and then number 7, but I'll talk about 6 and 8 as well. So I'm going to skip this first section here because this is pretty much your note card. So you should have that studied and know those definitions and things so far. So let's move down to number 2 where we find asymptotes. So I said I'm going to do A, D, E, and G. So for A, it's asking us for y equals 2 over x plus 5, what's the vertical asymptote and what's the horizontal asymptote. So vertical asymptote always comes from the denominator. So we're going to look at this x plus 5. We're going to say x plus 5 equals 0. Just solve that equation by subtracting 5 and you get x equals negative 5. That is indeed your vertical asymptote, so we can just go ahead and write that as our answer. X equals negative 5. Let's see if it'll actually write here. There we go. All right, so the horizontal asymptote, we always compare the degrees. So the degree on top is always based off of the highest exponent on x. So since there is no x, we would say that the degree is 0. The degree on the bottom, for that x, we just have an exponent of 1. So the degree is 1, which is bigger than 0. So what we say is that this rational has a big bottom. Whenever we can identify a big bottom rational, our horizontal asymptote always is y equals 0. Moving along to number D, or letter D for number 1, we are going to start back with the vertical asymptote. So once again, we need the bottom set equal to 0. So 5 minus x equals 0. You can solve these any way you want. So in this case, I'm going to add x to both sides. And when I do that, I get 5 equals x. So our vertical asymptote is just x equals 5. Pretty much the same as last time, just looked slightly different. Always use the denominator for your vertical asymptote. Horizontal asymptote, we compare degrees again, and this time there's an x on top and an x on the bottom, so the degree is the same, and anytime the degree is the same, we're going to use this equation right here, y equals LC over LC. So what we need to do is look in front of those x's. So we have a 2 in front of the x on top and a negative in front of the x on the bottom. So our equation will be y equals 2 over negative 1. Well, 2 divided by negative 1 is just negative 2. So y equals negative 2 will be our horizontal asymptote. So that one is a little bit more tricky for the horizontal asymptote, but always start by comparing degrees. The x on top and the x on the bottom match or are the same in terms of degree. So we need the equation y equals leading coefficient over leading coefficient. So 2 and negative 1 are the leading coefficients to give you negative 2 right there. Looking now at E and G, we see that we might not be able to jump straight into the problem like we did last time. So what do I mean by that? I mean x plus 1 over x squared minus 4 can factor on the bottom. So down here below this section, I'm going to factor the bottom. So we're going to get y equals x plus 1, doesn't change on top, but x squared minus 4 will factor as a difference of squares with x minus 2, x plus 2. The next question we would want to ask ourselves is, can we cancel anything? Because if we cancel, that makes a whole, not a vertical asymptote in the denominator. X plus 1 does not cancel with x minus 2 or x plus 1, so both of these pieces will make a vertical asymptote. So x minus 2, we can set equal to 0 and get x equals 2. And x plus 2, we can set equal to 0 and get x equals negative 2. Therefore, we have two vertical asymptotes this time. So we'll just list both. X equals 2, comma, x equals negative 2. Now for the horizontal asymptote, nothing really changes. All we have to do is compare the degree on the top with the degree on the bottom. So if we look, there's just an x on top, which means my degree is 1. And there's an x squared on the bottom, which means my degree is 2. Once again, we have a big bottom, so both A and E had a big bottom. Whenever that's the case, our horizontal asymptotes automatically y equals 0. So moving along to G, the last one from this section, we are looking at y equals 2x squared over 2x squared minus 8x. This is, in fact, the hardest one because you have some factoring, some canceling, and then you got to figure out vertical and horizontal asymptotes still. I'm actually going to start with the horizontal asymptote this time because finding the degree is always just looking for exponents. So the degree on top is, once again, 2, or actually we haven't had 2 on top yet, but the bottom is also 2. So we're looking at a same situation. So we need the equation y equals LC over LC. See if I can make it actually say LC. So we're going to look in front. 2 and 2 are in front of those x's. So our equation is y equals 2 over 2. Well, 2 over 2 is just 1. So our horizontal asymptote is y equals 1. So not too difficult there. But when it comes to vertical asymptotes, we have to factor. So let's go ahead and factor this. We have y equals 2x squared on top still. And then on the bottom, 2x squared and 8x have a 2x in common. So we'll factor that out and put x minus 4 on the inside. So you might see now we can cancel this 2, and we can cancel one of the x's on the top with the 1x on the outside on the bottom. So I'm going to show that by just crossing out that exponent. So all we have left is x over x minus 4. Well, when finding vertical asymptotes, if you canceled stuff, you can now ignore it. All we want is what's left in the denominator after we've simplified. So we're going to take x minus 4, set it equal to 0, and then solve. And we find that our vertical asymptote is x equals 4. That factor, 2x, would create a hole, and so that hole would relate back to a domain restriction, but not a vertical asymptote. Moving along to the second page, we're going to look at 2 and 3 and 5 from this next section. Number 2, we're not going to look at the graph. So let's go ahead and slide down to that section here. So number 2, we are just going to do all of these features. Domain, we're going to skip range, vertical asymptote, horizontal asymptote, x-intercept, y-intercept, holes, and end behavior. So I'm going to follow the order that our note card has been written in. So our domain is always based off of the denominator. But first things first, we should factor and simplify. So x squared minus 9 is one of those differences squares. So we have x minus 3 times x plus 3. And then on the bottom, 3x minus 9 has a 3 in common with x minus 3 left over. You might notice now that we can cancel that x minus 3, but before I do that, I want to consider my domain. So domain always comes from denominator, so we take x minus 3 and set it not equal to 0, which tells me that x does not equal 3. So our domain is always all real numbers and then what we're not equal to. So we're not equal to 3. So you can see right there that we have all real numbers, x does not equal 3. Now I'm going to go ahead and cancel x minus 3 and x minus 3, leaving me with x plus 3 on top and 3 on the bottom. Well, Since we canceled, I'm going to go down to my whole section. And so that whole is based off of that canceled factor. So I know that x equals 3 for that whole, but we don't just need an x value, we also need a y value. So we're going to plug in that 3 into our simplified equation. So what that looks like is f of 3 equals, anywhere you saw an x and x plus 3 over 3, we replace with a positive 3. So we have 3 plus 3 on top, divided by 3 on the bottom. 3 plus 3 is 6, divided by 3 is just 2. So our whole is at 3 for the x, 2 for the y. Awesome. Next thing would be our vertical asymptotes, but let's take a look right here. My denominator in the simplified is just 3. Well, there's no x's, so I actually can plug any x value into that x on top because there's nothing that's going to make a 0 on the bottom. So because there's no factor with x on the bottom, we actually don't have a vertical asymptote. There's none. The last thing that we set equal to 0, though, is our x-intercept, so that's where I'm going to move next. So for the x-intercept, we always take the top, x plus 3, and set it equal to 0. So x plus 3 equals 0. Solve that, and we get x equals negative 3. Writing it across the top here. But the way we write our x-intercept is as an x followed by a 0. So it's negative 3, 0 there. Excellent. So now we have horizontal asymptote, y-intercept, and end behavior because we're going to skip range. So the horizontal asymptote and end behavior are related, so we'll save those to the last. The y-intercept follows nicely from the x-intercept because we're using a 0, but we're actually just going to plug in 0. So what we're going to get is y equals 0 plus 3 over 3, which simplifies nicely to 1. So our y-intercept on this one is 0, because the x value is always 0, comma, 1. Awesome. So end behavior, we've done several times now, is finding the degree, comparing it, and then stating whether or not we have a big bottom, big top, or the same degree. So in this case, we have x squared on top and x on the bottom. So the degree on top is 2 and the degree on the bottom is 1. So we, in this case, have a big top. If we have a big top, there is no horizontal asymptote. So we would say none. Awesome. Therefore, for end behavior, we're going to have somewhat of a normal answer. So what I mean by that is it always says as x goes to infinity, where does f of x go? Well, see if I can write this somewhat clearly. My technology is only working so well today. Awesome. So there's our general format. We usually just fill in an infinity. In this unit, we learned that we put the number from the horizontal asymptote. But if we have no horizontal asymptote, then our end behavior would have to be based off of the graph. Or if you remember from polynomials, we can go based off of degree and leading coefficient. So degree and leading coefficient here of this guy, x plus 3 over 3, is a degree of 1, which is odd, and the leading coefficient is 1, which is positive. So odd, positive is down on the left, up on the right. So that would be infinity for x goes to infinity and negative infinity for x goes to negative infinity. In general, this question right here is one that is somewhat unique in terms of this unit. So I want to do all of number 3 with you because number 3 is much more standard, much more typical, what you should expect to see from this unit. So let's go through number 3, and we're going to graph this one together as well. So we have f of x equals 4 over x minus 3. We don't have any factoring or canceling to do, so that we can just automatically go straight to finding the domain. So we take the denominator, set it not equal to 0, and that's going to tell us what we get out of our domain. So we have all real numbers except x does not equal. Well, if we move that negative 3 over to the 0 side, we would get positive 3 there. So x does not equal positive 3. Since we didn't cancel anything, we can automatically go straight down to vertical asymptote and just reverse the not equal into x equals positive 3. So we have x equals positive 3 is our vertical asymptote because both the domain and the vertical asymptote come from the denominator. For the x-intercept, we take the top. So we're going to say 4 equals 0, but that's a false statement. If you ever get a false statement, you don't have x-intercepts. So we have none. We also, as I mentioned, don't have any holes. So we're going to put none for that as well. And then moving on to y-intercept, we take the equation and plug 0 in for all of the x's. So 4 on top, 0 minus 3 on the bottom. Our y-intercept will therefore be negative 4/3. The way we write that, though, 0 comma negative 4/3. Always write it as a point. So now all we have left other than range, which once again we'll skip, is horizontal asymptote and end behavior. So for the horizontal asymptote, we look at the degree. The degree on top is 0, and the degree on the bottom is 1. So we have a big bottom. That means that our horizontal asymptote is automatically y equals 0, which means our end behavior is automatically 0. Yes, it would technically be written out as the long, as x goes to infinity, f of x goes to infinity type of thing, but we are just going to put 0 for now for shorthand. So now we've got all the information. Let's go ahead and translate that over to the graph. So I'm going to start with my asymptotes. Vertical asymptotes, x equals 3, so I go to x equals 3 and draw a dashed vertical line. And the horizontal asymptote is also 3, but it's y. So we go to y equals 3 on the y-axis and draw a dashed horizontal line. So now you can kind of see your 4 sections. Your next job is to put your points. We only have the y-intercept, so we put 0, negative 4/3, which is about right here on the y-axis, which means I have a curve that goes in this section. I didn't like that. So let me draw it again. Here we go. And then we always go diagonal from that other curve. So I'm going to put another section right there on the top right. That's pretty much it for graphing a rational. You draw in the asymptotes, figure out your 4 sections, put in your points, and then draw the curves. You do need to know the shape. It is 2 pieces, and they go diagonal from each other. So let's do this again on number 5. Number 5 is on the top of page 3, I believe. So we're moving on to the last page here. Number 5 gets a little bit more tricky in that we have to factor and simplify first. So x squared minus x minus 6 requires an x puzzle. So we have negative 6 on top and negative 1 on the bottom. Well, negative 3 and 2 multiply to negative 6 and add to negative 1. So our factors are x minus 3, x plus 2. The bottom is the difference of squares, x squared minus 4. So that will always factor as x minus 2, x plus 2. So what we automatically should do first, now that we factored, is our domain. Domain is always based off of the denominator, so x minus 2 doesn't equal 0, and x plus 2 does not equal 0. If you solve both of those, you'll get x does not equal -2 for this one right here, and x does not equal +2 for the bottom one. So our domain would be written as all real numbers except for -2 and +2. Awesome. So moving right along, we're going to go back and cancel. I notice that I have an x plus 2 on top and an x plus 2 on the bottom. If I cancel those, that means I have a hole. So when you cancel, you take that factor, set it equal to 0, and that tells you what the x value of your hole is. X equals -2 is the x value, but we always need both an x and a y. So let's simplify the rest of our equation. So I'm going to move it up a little bit. All we have left on top is x minus 3. And all we have left on the bottom is x minus 2. In order to figure out the y value of our hole, we need to plug in our -2 from the x value into that equation that we just wrote. So y equals -2 minus 3 on top and -2, minus 2 on the bottom. Sorry, it's a little sloppy there, but our final answer is -2 minus 3 is -5. -2 minus 2 is -4. -5 over -4 is just 5/4. So our hole is -2 for the x value, comma, 5/4. Awesome. So let's go back now and do our vertical asymptote. Well, the vertical asymptote is always based off of the denominator. So the denominator of the simplified, this guy, is x minus 2. So for the vertical asymptote, we just need x minus 2 equals 0, which tells us that x equals +2. So this is a case where the vertical asymptote does not automatically match the domain because we had a hole. If -2 showed up in the hole, you should not put -2 as a vertical asymptote as well. All right, so moving along, the last thing we set equal to something is the x-intercept. So let's take that numerator, x minus 3, and set it equal to 0. So x minus 3 tells us that x equals 3 is our x-intercept, but that's not how we write x-intercepts. We always put the x value, comma, 0 for the x-intercept. Awesome. So for the y-intercept, this is the first thing on our note card that we don't set something equal to 0 to solve for. What we do instead is plug in 0. So go to your equation, x minus 3 over x minus 2, and substitute 0 in for all the x's. So 0 minus 3 over 0 minus 2 tells me that y equals 3/2. So our y-intercept is a lot like our x-intercept, except the 0 comes first. And the number comes second. So we have 3/2. Let's see if I can get it right there. Does not want to work for me right now, unfortunately. Let's see if I can get it here. 3/2. Excellent. There we go. So there's our y-intercept. Our last two things are horizontal asymptotes and end behavior. The horizontal asymptotes and the end behavior are always related. So let's start by finding the horizontal asymptote. If we look at our simplified equation, or you can look at the original one, either one works, we have a matching degree. So we have the same degree, which means we automatically need y equals LC over LC. So if we go in front of x, we have a 1 and a 1, which tells us that our horizontal asymptote is y equals 1. Therefore, our end behavior will also be 1. Cool. So now we have all the pieces. Let's go ahead and put it all together on the graph here. starting with our vertical asymptote, we have y or x equals 2. So let's put a dotted line at x equals 2. And then our horizontal asymptote is at 1. So we just need to go to the y-axis and draw a dotted line at 1. Then we do all of our points. This time we have 2 points and a hole, so we need to consider all of those when putting them down. I'm going to start with the points themselves. So the x-intercept is 3, 0. So that's right there. The y-intercept is 0, 3 halves. So that's about right there. So this is a rare situation in which you have a dot on both of the sides that you need to draw your curve. So that's really nice. And then the last thing we need to consider is our hole. So the hole is at -2, 5/4. So -2, 5/4 is about right here, but I don't put a dot. I put an open circle because I'm showing that it's not a part of the graph. So I draw my curve through my point, but not through my hole. So I skip over the hole, and that would be section on the top left, and then I have a section on the bottom right that looks like this that goes to that point. That graph would be 100% right there as long as you have all of those things together. So now we've practiced horizontal asymptotes, vertical asymptotes with number 1. We've done 2, 3, and 5 with some graphs on 3 and 5. Now looking at number 6 through 8, we're going to talk about some of this and only do number 7. So 6 through 8 is asking you to write a rational function based off of information given. So for instance, number 7 says write the equation for a rational function with a vertical asymptote at -3 and 4, and a horizontal asymptote at y equals 0 with an x-intercept at x equals 5. So it's giving you some information. It wants you to go backwards. So there's some important things that you need to know in numbers or in all of these problems. But if we're going to do number 7, some important things you need to know. A rational function always is y equals and a fraction. So you can automatically go ahead and start with that, and then you're going to fill in from there. Let's start with the vertical asymptotes. Those come from the denominator, and the numbers are the opposites of the factors. So for instance, if we have x equals -3, the factor that was in our denominator was x plus 3. So I'm going to put x plus 3 down on the bottom. Then the other one was x equals 4 for a vertical asymptote. So that factor would be x minus 4. So there's our 2 denominator factors for now. We might have to add more, but for now we've taken care of the vertical asymptotes showing up in this rational. The horizontal asymptote is y equals 0, which always relates to the degree on the bottom being bigger, so it's a big bottom. So for now, we can't really do anything with that, but we might use it to check ourselves at the very end. The last piece is this x-intercept at x equals 5. Well, if x equals 5 for the x-intercept, that means that the numerator solved to x equals 5 when we set it equal to 0. So if we go backwards from that, the factor itself was x minus 5 in the numerator. So if we put that factor up top, we can see we have an x-intercept at 5, 2 vertical asymptotes at -3 and 4, and now we just need to confirm that our horizontal asymptote's at 0. If it is, then we've done this whole problem. So the degree is always based off of exponents, but we have factors, not terms. So when we have factors, the degree comes from adding all of the exponents. So on top, we have a 1. On the bottom, we have 2 x's. Add those exponents together, which gives us a degree of 2. So the bottom is indeed bigger because the degree on the bottom is 2, whereas the degree on the top is 1. So this would be your final answer for number 7. It's basically just working backwards with the ideas that we just practiced on number 2, 3, and 5. This type of question would be a bonus. So ultimately, nothing too serious to think through here. Don't overwhelm yourself by trying to master number 6, 7, or 8. The one tricky part about number 8 is that the information is given on a graph, but you can figure out asymptotes and all that from a graph nonetheless. So I hope these helped. I hope you have a great day as well.